Oh, probably.
You were right?
How bad, Joe?
Yeah.
Okay. So what'd you guys do? What'd you switch?
All of them.
All of them. Okay. Tell me what you did with cosecant.
1 over sine.
Okay. What'd you do with cotangent?
Cos over sine.
You did cosine over sine?
Yeah.
Okay, and so you guys, I think Miss Jolie was asking me about this.
What?
Oh,
What?
that's not right? Sorry. That's what I get for thinking it. Okay, so cosine over sine, you said. Okay, sorry. I was in the middle of trying to explain something. So what Jolie was asking me is, how do you know which one to use? Like, typically she said, why don't I write 1 over tangent in this case? And part of it is just realizing, like, is there another tangent in this problem? I don't see it. So if kind of trying to think a few steps ahead, and then sometimes you, like, let's use 1 over tangent, and you're like, well, that didn't work, let's go back, you know? So sometimes that's why there's more space here. Sometimes you head a direction, and it's just not very helpful. It's kind of a little bit of a chess match, so trying to figure that out. How about secant?
1 over cos.
Okay.
That's true.
So now it looks like we just made a bigger mess of ourselves here. That's it. That's as simplified as it gets. No, I'm just kidding. So fraction within a fraction. What can we do?
Multiply by cosine.
So we can keep switch flip. We can do that idea. So we can, so the top's gonna stay, or do you guys want to multiply this together? Is that what you did?
Yes.
So we have we clearly have cosine of theta over, what's sine times sine?
I don't know.
Sine squared.
So you can write it as sine squared times, flip this.
Uh-oh,
Okay.
spaghettios.
Uh-oh, spaghettios.
All right. So we're left with cosine squared over sine squared. Okay, guys. All right. Now, technically, I said try to get everything in cosine and sine. However, we have 2 trig ratios, or 2 trig functions in this one. Is there any way to write this as 1 trig ratio or trig function?
No.
I don't know. Can you just look at this?
You can't cancel because the squares you can't just cancel because they're not like term.
I just
No, because there's not 2 sides of the equal. That works only if there's like 2 sides of the equal sign. What do you think? Yes, cosine over sine is just cotangent. So just let's go down to one simpler. But yeah, it's cotangent squared because they're both squared. And so if I'm talking about simplifying things, is 1 better than 2? Yeah, like 1 trig function is better than 2. So I would say to go that 1 step further because this seems more simple than that. So again, this whole nonsense simplified down to just be cotangent squared. Okay, so that would be considered simplified. All right. You agree? All right. No, there's homework. I just didn't have room to write it down there. All right. All right. Give you guys a minute to try this. I'll talk about this one in a second. I'll give you guys a minute to get started. I think allowing you guys to try it's good for you guys to get practice. I hope it's not like defeating your confidence. It's supposed to give you a chance to think a little bit. Oh, okay. time?
I think I got it. What'd you get?
All right. Yes, so actually, Erica mentioned order of operations. She said PEMDAS. And order of operations is important for this. Just being aware that we should be like kind of keeping these two separate. Like multiply is focus, like multiply before you add or subtract. But the idea is you don't just like get to like move things around however you want. All right, where do you guys want to start? The secant. Let's fix that. So this is 1 over cosine. Oops. And I'm going to put this cosine over 1, right? So, they still became 1, right? Yeah. Okay. So these two cancel, right? So I have 1 over cotangent squared x plus 1. All right. Thoughts? What do you think?
That was good enough.
That's the same thing as saying tangent squared.
Yeah. So 1 over cotangent squared. Remember, I said you can square those trig identities that aren't squared, and we see the rule that, you know, cotangent is 1 over tangent. So 1 over cotangent is just tangent. So this becomes tangent squared x plus 1. So this becomes that. Take a minute to like kind of see that. So that tangent's the same thing as 1 over cotangent. Same thing with squared. Now, are we okay? No? What do you see about this? That exact thing is written on our paper somewhere. What does that equal?
Equals secant.
Oh,
Squared.
I was looking at everything but the one right now.
And yeah, it's just a matter of figuring out what your strategies are and what you know. You guys, this is not something that the first time you do it, well, maybe some of you, it's like first time you get into it, it makes total sense. But it's not, if you don't know your tools yet. It's just, I mean, I think Carter was saying this to me one day, like at first it all sounds so hard. This is something brand new to you guys. Stop talking, guys. This is something brand new to you. It's you're learning a new language. It's a different than you've ever done before. It's okay. It's okay to like struggle and have to figure it out. So again, there's gonna be times you're gonna hit a roadblock, and you might even see me do that up here because I don't have my cheat sheet up here, my answer key, because, and I haven't taught this since I was at Cedarburg. So like this is something that there's times I'm gonna go in a direction. I'm like, what did I do? I got nowhere. So let's work our way back around. You know, there's gonna be times that we have to restart. At the same time, it's something after years of practice, I've gotten better at it. Like it comes more naturally to me. Now, this next one, this is trying to rely on your algebra skills a little bit. Because this problem, this should like kind of start kind of giving you kind of a little bit like ideas about what you know about something that looks like this. Because this is something we see pretty often, we've just never seen it with trig. We don't have anything that has secant plus 1 or secant minus 1. So right now, like those Pythagorean identities aren't going to be very helpful for that. Does anyone have an idea of why I said this should be something you're like, oh, I know what to do with that? What do we call it? We had a name for these types. Yeah, it's that conjugate. You don't have to know the name of it, but this is the same thing as seeing, you know, x minus 5, x plus 5. You should see something something like this and be like, oh, like I know that those middle two are gonna cancel. This is something that foiling it is not so bad because I know those middle two terms are gonna cancel. So that's why we did that algebra practice, not because I just wanted to do algebra with you. It's nice to do algebra with you for a day. However, this is that conjugate, so try foiling. So Sam, I would try foiling on this. Oh, is that you're doing that now?
Yeah.
Okay, no, you're fine. Sorry, I saw what you were doing at first, and I was trying to stop you. The reason why foiling is so good here is because those middle two terms will cancel, and I'll be left with just two terms. And we like squares. Yep. Yep. You can take a break after this, but yeah, if you wanna.
That's what Gavin wants. You should.
And getting used to writing secant squared, I mean, it's just something that's new to you. So these middle two will cancel. Once we're at this point, I'm hoping, again, anytime you see squareds, I usually start squareds and ones, typically. I think of the Pythagorean identities, but again, this is just something you guys are going to get better at and better at. Like, hopefully you notice, what is this going to be the same as? It's going to be, yeah, so like, and actually, we have this exact one on the other side of our salmon sheet. It was number 5 down there. But we have tangent squared theta plus 1 equals secant squared. So secant squared minus 1 is just tangent squared. And again, I kind of asked myself, am I done? I have one trig ratio, or one trig function. There's only one term. I'm probably pretty good at this point. So I am going to stop and do announcements.